Imagine AI that can look at a photo and not just say, oh, there's a cat, but actually understand what's happening in the picture. Like, the cat is on a bookshelf, eyeing a goldfish. That's the future of vision language models, or VLMs as they're called. And on today's deep dive, we're looking at the open source VLMs that are changing the game.
What's exciting is the shift we're seeing. These powerful AI models used to be hidden away, tucked away in big tech labs. But with Molmo and its datasets, PixMo, we're entering a new era of transparency and accessibility in AI.
Okay, so Molmo's the AI and PixMo is the data it learns from, right? What makes Molmo stand out from the crowd?
Molmo's special ingredient is its modular architecture. It's built in 4 parts: the image preprocessor, the vision encoder, the connector, and the language model. Each has a specific job. But the fascinating part is how Molmo actually sees images.
Okay, you've got my attention.
Yeah.
How does Molmo see things differently?
Well, instead of trying to analyze a whole image all at once, it breaks the image down into smaller crops, like looking at a painting up close, brushstroke by brushstroke, before stepping back to take in the whole picture. This lets Molmo handle those super high-resolution images and pick up on the little details that other models miss.
It's all about the details, isn't it?
Right.
Especially if you want to understand complex images with lots going on. Does that make Momo more accurate or faster?
It does both, actually. Focusing on smaller chunks of information means Malmo can process high-res images without getting bogged down. Sort of like multitasking, you can get more done if you break a large task into smaller steps.
Smart AI indeed. But AI is only as good as the data it learns from, right? Let's talk about PixMo, these revolutionary data sets that are fueling Molmo. What's the big deal here?
You know, the biggest problem with AI data is that it's often made by other AI, which creates a kind of echo chamber, limiting true innovation. Imagine if you only learned a language from textbooks and never spoke to a native speaker.
Right, it would sound pretty artificial. You'd miss out on all the nuances and real-world stuff.
Exactly. And that's where PixMo comes in. It takes a radically different approach. Gathering data without relying on other VLMs or synthetic data they create, it's genuinely open.
That's a refreshing change. So tell me more about these PixMo datasets. How do they actually get this unique data?
Well, there's PixMo which focuses on getting detailed image descriptions. The clever bit is that they have annotators describe the images verbally, like they're giving a tour of what they see. This gives richer descriptions that capture not just what's in the image, but also how a human sees and understands it.
That's clever. It's like they're tapping into the human ability to, make sense of visual information.
Yeah.
Does this approach make a difference in the data?
Oh, absolutely. Much richer data, capturing all those nuances of human perception. Plus, they record the annotator's audio, creating a sort of receipt to prove no other VLMs were used. They even have PixMo Ask Model Anything, where users submit questions about images. And a language model helps refine the answers to make sure they're accurate.
It's like crowdsourcing image understanding. Any other types of data sets in the PixMo family?
There's also PixMo Points, all about connecting language to specific pixels in an image. This lets Molmo understand images incredibly precisely, even allowing it to count things. Like not just telling you there are apples in a picture, but actually counting them.
That is impressive. Okay, so we've got this amazing VLM architecture, these groundbreaking data sets. How does it all come together? Talk to me about the training process. How do they teach Molmo to be a VLM superstar?
Training Molmo is surprisingly streamlined. The richness of PixMo means they don't need to train the connector separately. Molmo learns super efficiently using a technique called the overlapping multi-crop strategy to get the most out of each image.
Okay, that sounds technical. Overlapping multi-crop strategy. Can you explain what that means?
Imagine a chef meticulously chopping veggies, making sure every bit is used in the dish. That's essentially what's happening here. Molmo takes those smaller image crops and analyzes them to maximize learning from each pixel. All about efficiency.
So nothing goes to waste. What other tricks do they use during training?
Well, they also cleverly handle multiple annotations per image, which is like getting multiple perspectives on a piece of art. This lets Molmo learn from a variety of interpretations, making it even more adaptable.
So it's not just about seeing, it's about understanding different ways of seeing.
Exactly. And here's a real light bulb moment during pre-training. They use text-only dropout. They randomly remove words from the text descriptions, forcing MoMA to rely more on its understanding of the image itself, not just on language patterns.
So they're pushing Molmo to be less of a bookworm and more of a visual detective. Now that we've covered the basics, I'm dying to know how Molmo performs in the real world. How does it stack up against the big names in the VLM space?
Well, they put Molmo head-to-head with some of the heavy hitters: GPT-4V, GPT-4o, Gemini, Claude, And guess what? It held its own. They even used an ELO rating system, like in chess, to see how it ranked based on human preferences.
Wait, Molmo, an open source model, is competing with these giants. Did it actually win any of these matchups?
The results are fascinating, and we'll get into all the specifics of how they trained and tested Molmo in the next part of our deep dive. You won't want to miss it. Welcome back to our deep dive into the world of open source VLMs. We left off with Molmo facing off against the big leagues, and I promised we'd get into the specifics of how they trained and tested Molmo, because that's where things get really interesting.
You've definitely got me hooked.
Yeah.
We've got this innovative architecture and these impressive data sets, but how do they turn Molmo into a VLM powerhouse? What's the training process like?
It all starts with pre-training. They feed Molmo a huge amount of data from PixMo cap. Remember those highly detailed image captions we talked about?
Yeah, like boot camp for VLMs, getting Molmo into shape?
Exactly. They show Molmo an image and tell it to generate either the caption or the audio transcript. It's a giant game of describe what you see, but for AI.
Makes sense. But I imagine training a VLM is super complex.
Mhm.
Are there any special strategies they use to make the process better?
Actually, they've simplified things quite a bit. Many VLMs need a whole separate training stage just for the connector. You know, the part that bridges the vision and language processing.
Right, the one that helps them understand each other.
Exactly. But Molmo skips that step entirely. Thanks to the richness of the PixMo data, the connector learns right alongside the rest of the model.
So it's a more integrated approach. Learning by immersion, so to speak. Does this actually make a difference in the training?
It's incredibly effective. This integrated approach saves time, reduces complexity, and they don't need to use all that noisy web-scale data that's typically used for separate connector training.
Less noise, more signal.
Uh,
I like it. So once Molmo graduates from boot camp, what's next? How do they refine its skills?
Next comes fine-tuning, where they really polish Molmo's abilities. They expose it to a carefully selected mix of datasets, each targeting specific skills, like visual question answering with datasets like VQA v2.0, or understanding text within images using text VQA. They even use datasets designed for understanding charts, tables, and diagrams.
Wow, a comprehensive education. So it's not just about understanding images alone. It's about interacting with all sorts of visual information. How do they decide which datasets to use and how much of each?
They're very strategic about it. They sample datasets at rates proportional to the square root of their size. With some manual adjustments for really large datasets, this ensures Molmo gets a balanced and thorough education.
So it's a very calculated approach. Does this extend to the types of responses Molmo learns to generate?
Absolutely. They're very intentional about the style of responses as well. During fine-tuning, they use these task-specific style tags, so Molmo learns to tailor its answers appropriately. For example, answers for VQA v2.0 questions should be short and sweet, while answers for AOK VQA might involve multiple choices.
It's like teaching Molmo different dialects for different situations. So after all this intensive training, how do they evaluate Molmo's performance? How do they know if it's really a VLM superstar?
They use two approaches: academic benchmarks and, crucially, human evaluation.
Right, you need both the objective data and the human perspective. Tell me more about these academic benchmarks. What kind of test does Molmo have to take?
They evaluate Momo on 11 different common datasets, covering everything from visual question answering and counting to document understanding. They compare its performance to other cutting-edge VLMs, taking into account things like prompting techniques and the use of benchmark-specific training data.
Like a standardized test for VLMs, seeing how it stacks up against the competition.
Exactly. But then they take it a step further with human evaluation, which captures how people actually perceive Molmo's responses. After all, AI is designed to interact with humans, so their opinions really matter.
For sure. How does this human evaluation work? What are they looking for?
They put together thousands of these image-text prompt pairs and have Molmo and other VLMs answer them. Then they show these responses to human annotators who rank them based on their preferences.
So it's a VLM popularity contest. I'm on the edge of my seat. How did Molmo do? Did it win over the judges?
The results were impressive. Not only did Molmo hold its own against those big-name VLMs, it actually excelled in certain areas. Remember Molmo 1B, that incredibly efficient model we talked about?
Yeah, the one that's punching above its weight.
Well, it almost matched GPT-4V in both the academic benchmarks and the human preference ranking. That's a huge victory for open source AI.
That is incredible. Molmo is not only open and accessible, but it's also incredibly capable. This is a real game changer. But before we get too carried away, let's dive into some of the specifics of these evaluations. What were some of the standout findings that really showcase Molmo's strengths?
There are some really fascinating details that demonstrate the power of open source development and Molmo's unique capabilities. Let's explore those further in the final part of our deep dive.
Welcome back to the Deep Dive, where we're exploring Molmo and PixMo, the open source duo shaking up the world of AI.
You got it. We've seen how Momo's architecture and PixMo's data gathering methods, well, they've led to some remarkable achievements.
Yeah, absolutely. You mentioned some kind of hidden gems, though, details that really highlight Momo's strengths. What surprised you the most?
One really striking finding is Molmo's adaptability with different vision encoders. They experimented with several, including CLIP, SIGLib, and even the completely open source Metacliplib. And you know what? They all performed incredibly well.
So it's not picky about its visual input. It can adapt to different ways of seeing, so to speak. That's pretty amazing flexibility. What other unexpected findings were there?
Well, the results from the human evaluation were particularly interesting. Remember Molmo going head-to-head with those big-name VLMs in a sort of popularity contest?
Yeah, the VLM showdown. Who took home the crown?
Momo consistently scored high in terms of user preference, especially in tasks like counting and image description.
So it's not just about passing those academic tests. It's about giving answers that real people find useful and engaging.
Exactly, and this really says a lot about the quality of those PixMo datasets, those detailed captions and user-generated questions. Well, they seem to be training Momo to communicate in a way that really resonates with humans.
It sounds like they've hit on something crucial for human-AI interaction. But let's be real, no AI is perfect. Were there any areas where Malmo struggled?
That's a good question. They did find that Momo's performance on certain tasks could be sensitive to the number of crops used during training and testing.
You mean those smaller image sections that Malmo looks at individually?
Yeah, exactly. They noticed that if the number of crops used during evaluation was different from what was used during training, performance could drop, especially for things like captioning and pointing.
So Malmo gets used to seeing the world through a certain lens, and changing that lens can throw it off a bit. It's like having to suddenly wear a different pair of glasses.
That's a great analogy. But they did find a workaround. A bit of fine-tuning at a higher resolution helped Molmo generalize better across different crop settings.
So adaptability is key, finding ways to make Malmo more robust and versatile.
Exactly. And that's one of the best things about open source development, the ability to find these limitations and work together to overcome them.
A constant evolution, pushing the boundaries of what's possible with VLMs. What's next for Molmo and PixMo? Where do they go from here?
Well, the team is already looking ahead, exploring ways to make Molmo even more capable, experimenting with different training techniques and new types of data.
So it's not a one-and-done project, an ongoing journey of discovery and innovation. That's the beauty of open source AI, isn't it? Always evolving and improving.
Absolutely. The possibilities are limitless when we share knowledge and work together.
It's been an amazing deep dive into the world of Molmo and PixMo. I feel like I've got a whole new understanding of open source AI, its power and its potential.
Glad to hear it.
For all of you listening, I encourage you to check out the Molmo website, explore the codes, the data, maybe even join the movement. Who knows what amazing breakthroughs we can make together. Until next time, keep exploring.